Hello, everyone. Hello, hello.
And hello to you too.
Yep. How is your computer now?
I just sent you a note. They just put it in. I'm trying to download everything.
Okay.
But I think I'm going to get Cordis to run. I had trouble with programs yesterday because Cordis was just screwing up. So I hope that it's better today.
Okay, good luck with it.
Boy, do I need it.
Okay.
I'm not as smart as these young people that are in the class.
Okay. You feel younger and you will do it. Now we are ready to start our lecture. I'll share the screen. We spoke yesterday, or we had a reminder yesterday about the architecture of the main component in ARI VHDL module. We said we're going to start with library, and we are declaring the packages that we are using. Then we have entity. The entity is to specify the IOs that will be used in our program. Input, output, and what type of input, output. Then I go to the architecture. Architecture could have a component, or it may not, and it may have signals or may not. But for sure, I must have a body for this that starts with begin and ends with end. I'm busy right now, I show time. So this is how it would look like. The library, and those are the standard logic of IOs as we spoke about them, and the operators. And this is an example of how the AND would look like, and this is AND OR, and I believe you did that yesterday in the lab. This one is just to generate a clock. Can you see clock? It assigned to not clock. That's mean I'm inverting. Every time I go and come back, I will invert the status. So this is to generate a clock. And this one is a new example. Suppose that I have 4 AND gate. Each one is getting A0, the second one A1, A2, A3. So I have a vector of 4 digits for A and 4 digits for B. I can declare them in one shot. I can say that A is a standard logic, and it's going to be from 3 to 0. 3 to 0, as you can see here, A standard logic vector, and it is 3 down to 0. 0, 1, 2, 3, 4. B will be the same thing, 3 down to 0. And C will be 3. This will be my output. Before, we used to see it as just integer, 1 digit. But here, if I use the standard logic library, the package, I can declare arrays. Let's see how the previous circuit would work, this one. Here I am saying A will be a standard logic from 7 to 0. This is 8-bit. 8-bit. And this will be input and the output will be Y. And here I am ANDing the 8 bits. The 8 bits I'm ANDing A7 and A6 and A5 and A4, A3 and up to 0. This is a very simple circuit, 8 input and gate.
Professor, I have a question.
Yes.
Can you go back one slide? So let's see. A and B are your two inputs for a single AND gate, and C is your output. So in your VHDL description, why do you only AND the A inputs and not the B inputs?
Oh, for this one?
Yes. Or is this a different example?
No, this is a different example. This is a different example.
Oh, okay.
The
This
whole
is,
A, and this is
just
input.
Okay, I
not
see. So this
4.
is just a syntax example?
Yes. Yeah. No,
okay,
no, just.
Okay. Thank you.
By the way, if you go to your homework, you are going to see this. Number 1, 8 input and gate. It is this program, 8 input and gate. This will be part of your homework. All what you need to do is to run, of course, you need to code it. So you need to run this program. And I believe after our lab yesterday, you are very well acquainted with writing VHDL, and we had a lot of time debugging it and knowing where the errors might be and how to generate a waveform and run and see the simulation. For all homework, it says at the bottom, we are going to have, believe it or not, 11 programs, 11 programs for homework 1. I need 1 PDF file. This will have the code and will have screenshot of the waveforms of the output input for those 11. Clear? Hello, hello.
Yes, Professor.
Is it clear?
Yes.
Okay.
Are you gonna help us go over how to make like multiplexers or flip-flops?
How? When we come to it, they're all in here.
Okay, thank you.
They are all in here. This is an inverter. This is an inverter, and I'm saying this inverter a vector 3 to 0, and I have Y, this is the output. I can see here that I am inverting all A once. Y, not A. I'm giving you just very simple examples to sharpen your appetite with this VHDL. I have another example. Not all the examples you are required to do, but for this one is 4-bit wide gates. I have A and B. Those are my inputs. And I have Y1 to 5. Each one is 4-bit wide. What do we do here? I am saying Y1, A and B. This is OR XOR, NAND, NOR. So I'm using all 5 of them. And I'm using the whole 4-bit together. Any questions? Of course, we have seen before I can deal with 1 bit at a time, or I can deal with the whole string. We had this demo of the AND that I showed you yesterday in our lab. Now let's see this multiplexer. What is a multiplexer? As you had it in logic, electronic logic circuits, we had here two inputs. One will be selected to go out, and the other will be waiting. I need that. Suppose that I have 10, not just 2 inputs, 10 inputs. 10 inputs coming from 10 sensors. But I have one port in my microcontroller. Microcontroller has only one port that can receive at a time, but it is very fast. So I am selecting one input at a time to send its data to the output. How could I select it? By this S selector. For this 2 input, if S is 0, I0 will be out. If S is 1, I1 will go out. So I'm selecting which one will speak to the output. How can we write that? This is input, both input, standard logic, not vector. S is another input because it is my selector, and F will be my output. The entity is MUX2, so I have here architecture sense of MUX2. Here, please note that I have here what? I have here F equals I1. This is our first time to see when S equals 1. This is the selector. If S equals 1, I1 will be my F. Else, if it is not 1, what could it be? It has no option, no other option but being 0. So I will take I0.
Professor?
Yes, sir.
So you see how on line 15 it says architecture and then synth of MUX2?
Yes, this is the name of my architecture.
Yes. So when do you use synth and when do you not typically?
No, this is the name. This is the name of the architecture, not a duty of the architecture. This is the name, just the name.
Okay, thank you.
Okay. Can you see anything wrong with this program? Can you see anything wrong with this program? Can anyone see anything wrong with this program?
We're still looking.
Have you not specified?
Take your time.
Have you not specified else on the selector?
No, it is specified. When S is 1, that is I1 will go out.
Oh, I see what you're saying. Everything else.
Yeah.
Okay.
I'll tell you what, sometimes.
It looks like we have some semicolon errors there too.
Okay, what is it?
I think there should be a semicolon after the F And I don't,
Here, this is the whole
No.
statement.
in the entity statement,
Entity statement here.
MUX2 is port, and then you have IO, I1, S, and F. I think there should be a semicolon there.
Could be.
I think you usually
And-
leave it without a semicolon.
Yeah,
And in addition, this is entity MUX2.
uh-huh.
Sometimes it is accepted. In other occasions, I need to say end MUX2.
Yes.
If you get an error, you need to put here end MUX2. If it passes, okay. You have only one entity. But it is advisable to end MUX2. I have two multiplexers, but I have three inputs. I have two multiplexers and I have three inputs. One multiplexer can handle two, but I have now three inputs. How could I handle that? I have input A, B, C. One of them will go out on F. Can you look at this and tell me what is the condition for F to receive A? What should be D and E for F to receive A?
D and E should both select 1, right?
Yes.
As in D should select input B and E should select input A.
Now, if I want F to receive A, what should be the value of E?
It doesn't matter what D is. It's only what E is if you want A.
You have to be
Excellent.
1.
Yes, excellent. Thank you. Now, if I want to get C to be my output, what should be D and E?
0.
Which one? Both of them?
Well, I guess it only matters that E is 0.
No, it must be 0. E must be 0
Yes.
and D must be 0. Both of them must be 0.
Oh, right. Otherwise, it won't select C.
Yes, yes, yes. Now, let's see the code here. Is it right here? F equal A when E is high. Clear. Else it depends on B when D is high, else it will be C. Read it slowly and tell me if it makes any sense to you.
Do you want an answer?
No answer. I want you just to read, to understand. Does it make any sense? Yes or no? Is it good? Can you understand it? Do you have trouble understanding the statement?
Yes, yes, and yes.
Okay, so I can proceed then.
Professor, can you explain what the multiplexer is, please?
One speaks at a time, the others will be mute, please. Now, what is the question?
Can you please explain what a multiplexer is, please?
Multiplexer, it is a data selector. Either line I0 or I1 will go to the output. It depends on the value of the S selector. If S is 0, line 0 will go to the out. If S is 1, line 1, I1 will be the output. That is what's written here. F equals I1 when, if S is high. Else, what is else? If S is not 1, what's the other option? I don't have any other option but 0. Okay, so it will be I0. The same thing, I have it in here. But here I have 2 stages. The first stage, if E is 1, A is selected. A when E is high. Else, what is else? E is low. E is low, that means I have this line. And this line will be triggered by C or B, depending on what? On D. If D is high, I will get, if D is high, I will get B. So it will be B when D is high. Else, this is my last option. If D is not high, that is 0, I will get C. Clear? Do you want me to repeat it?
Question, Professor.
Thank you.
Question, please.
Yes, sir. Go ahead.
If we have D low and E high, do we get 1 at F?
Again, what is E is high?
Yes. If
E is high, I go here. E is high, so the output is A.
yes,
Done.
irrespective.
I don't go to any else.
Okay, awesome.
Okay.
Thank you.
Thank you, sir. Sometimes we use what is called process. A process can be in here within my architecture. And let's see what is it. A process, it is something that will happen due to a change in a status of something. Like, we're gonna give you an example. If I have a clock input, whenever the clock is going from low to high, I can do certain tasks. I can make the addition, I can make the subtraction, I can increment a counter. That is happening only when the clock is going from low to high. So in my process, which is a group of statements started by begin and ending by the process name, here I put the name, and this will be the by process, and that is the sensitivity list. What triggers the process? Let's see the example. It will be more clear than this one. This is called D flip-flop. D flip-flop, I have an output Q and its inverse. Q is following D. If D is high, Q is high. D is low, Q is low. And this is the inverse. Q inverse is the inverse of Q. Whatever Q is, I have it, its inverse. But Q will never follow D unless there is a rising edge of a clock. If we have a rising edge, this will trigger and D will be copied onto the Q. Let's see this D flip-flop that we can buy it as integrated circuit, how we can write a program to simulate it. This is my library. Input will be, of course, I have 2 inputs, D and clock, and I have Q is my output. Here, since everything is tied to the clock, nothing is happening unless there is a clock. So I'm writing a process. And this process, it is waiting for the clock. This is the end of the process. What do we have in here? This is our first time to see the if statement. If rising edge of clock, then D will go to Q. And if I don't have any else, just end if. If rising edge of clock, then Q will receive D. We can have another function. Instead of rising edge, I can have falling edge. Falling edge of clock, that is when we are making the trigger. So my process is triggered by the clock. That's why I put the clock right in here. And this is a D flip-flop. Clear? Hello, hello.
Yes, thank you, Professor. Thank you.
Okay. This is a more sophisticated D flip-flop. This has a synchronous clear, or we can call it reset. If I input here a high signal, the output will go immediately to 0. Will go immediately to 0. I don't wait for getting a permission from a clock. That's why we call it a synchronous clear. Whenever we have it, go immediately to 0. How could we write that? Process. What changes my process? What triggers the process? I have clock. And I have clear. Both of them are independent. Whenever any one of them occurs, there is something that will happen within this process. Let's see what is happening. If clear is high, Q will be 0, unconditional. That's it. Just whenever it is high, I will go, Q will be 0. Else if, after I finish with this condition, I started checking my rising edge. Do we have a rising edge? If yes, yes, D will go to Q. But the first trigger, or the first triggering of the process, is to check the clear. If the clear is high, well, I set to 0. Can you see it? Can you understand it? Is it clear for you?
Yeah, so you're saying the clear has all priority. So even if the clear is 1 and the clock is rising edge, it's still going to clear.
Yep.
But for other conditions, if the clear is 0 and the clock is rising edge, then it'll default to the D input.
Okay.
Awesome. Thank you.
Benrad? Hello, Ben.
Yes, Professor.
How may I change this? If I want the clear to take a permission from the clock.
We can
With the clock, I will clear. But if I don't have a clock, I will not clear. I will stay as is until there is a rising edge. How could I modify this architecture? or this process to accommodate that?
If we make high, would that, I'm sorry, declare low,
Yes.
would that change it?
Now, the first question to ask, who will trigger this process? In this example here, this is asynchronous. I have clear, I have clock, both of them. But if I have synchronous clear, the clear will not happen unless I have a clock.
Yes.
Do I need the clear here?
Yes, you do.
Why?
Because both have to be high.
Will it happen on its own? If clear,
No.
if clear is there, will I change the status or I should wait for clock?
You wait for the clock.
Yes, so if I remove clear from here, still the program will work. If you keep it, it will not hurt anything. But it is more logic that clear now is dependent on the clock. So I put here the list of independent inputs. But if you put an input that is not independent, okay, no problem. This is a second version of the D flip-flop, the third version of D flip-flop. This now are reset. It depends on the clock. It is not on its own. That is why I put here clock only. If rising edge, first thing to check, reset. If reset is high, Q will be 0. Else, Q will be D. Can you see here? I am ending this if statement of the reset, then rising edge, that is another if. It needs an end if. So I have two if statements. The first one, my main clock. If it is on, I would check for the reset. If reset is high, okay, go to 0 immediately, end. But if it is not high, I would go to else. In this case, I will check D, and whatever D is, I will send it to Q. Is it clear the difference between the two? This one, asynchronous clear, with this is synchronous reset. Since the sensitivity list has only clock, so I have here clock, because reset is dependent on the clock, not independent. A more sophisticated D flip-flop. What is this? I have a D input, okay. I have Q, this is the output. I am taking it over here. But I have the D flip-flop, it has this one input. So the output here will follow this input. But which one? Will I get D or will I get Q? This selector is selected by enable. if enable is 0, if enable is 0, what will be my output? Chad? Hello, Chad?
Yes, sir.
If enable is 0, will I get at this point, which will be reflected over here to Q? Will I get this Q or get D if enable is 0?
I believe you would get Q because
Excellent. Because this is 0, this is 1. This is line 0 and this is line 1. If enable is 0, I will get Q. That means no change in output. The output, whatever it is, no change, remain as is. But if enable is high, as the name implies, enable what? Activate D, let it go and pass and be reflected on Q. So enable, it is just to reflect D and enable D when it is high. And of course, that would never happen without a rising edge. And this rising edge will be also affecting the reset. So the reset will be the first thing to check. If rising edge and there is a reset, Q will be 0. Don't care about D, don't care about enable, don't care about anything. When there is a rising edge and reset, Q will be 0.
Professor, I have a question.
Yes.
So you said the first priority in terms of checking is the reset. Why is the reset not reflected in your architecture then?
No, this is reset. It is designed by this D flip-flop. Whenever there is reset, this is highest priority.
Right. So if that's highest priority, why is it not in our architecture for the D flip-flop?
Why it is not in the architecture?
Yes. In the previous example, you had the reset included in the process, but this time it is not here.
Oh, yes. It is not in the code here, you mean?
Yes, exactly.
Can anybody guess why it is not here? Can anybody guess? Hello, hello. Any guessing?
My guess is you just forgot to put it in.
Close enough. Or that is extra dose of marijuana. That is my other guess. Yes, you are correct. We are missing this. Here, my process clock, if rising edge, then if enable is 1, Q will be D. Else, there is nothing. Nothing will happen. Q will remain Q. I need your talent to add this reset to this program. Okay? Before we forget.
After the homework.
Yes. We had 8 input and gate. We covered it. We covered the 2 mux and the 3 input mux, where we had 2 muxes. We saw the plain D flip-flop. We saw the D flip-flop with clear. That is not tied to the clock. That's why it is on the sensitivity list. We saw D with reset. And finally, we saw D with enable. I believe we saw the 4-bit inverter and the 4-bit gates. When we said we have 4 input X and 4 input Y, and I am ANDing them or inverting them or doing X or whatever it is. Now we have counter and adder. What is a counter? Counter starts with 0, 0, 0 and waits until there is a trigger, a clock. In this case, the counter will increment. It will be 0, 0, 1 and stays in this position until there is another pulse, clock pulse. I go from 1 to 2 to binary, that is 0, 1, 0. Another clock, I go to number 3 in binary, that is 0, 1, 1. So with each clock, I am incrementing. How to do that? Clock, and of course, I need enable, count. Okay. Those are my IOs. This is a 3-bit counter. 3-bit counter. This is our first time here to see signal. And we are going to say why we needed signal. This is a 3-bit CNTR, and it started with 0, 0, 0. So I'm initializing it to the value of 0, 0, 0, as you can see it. So I have a process that depends on the clock. And if rising edge, okay, I'll check the enable. If I have enabled the counter to work, another input, what do we have? Counter equals counter plus 1. I am incrementing the counter. Can you see what's happening? I am incrementing the counter. Okay. Keep on doing that and get the CNTR to be my count. I go back again. If there is a rising edge, I increment. I have this, it was 0. Now I increment it to 1 and I put the 1 to out. Now I go back, increment. This is rising edge. So 1 plus 1 will be 2. I output 2, go back. If I look at this CNTR counter, is it from this statement an input or output? Is it input or output?
It's an input.
We know input is on the right-hand side. Output is on the left-hand side. Is it input or output?
Which portion were you referring to, Professor?
This CNTR, this statement. Out of this statement, you think CNTR counter is input or output?
Would be input.
Input because it is on the right-hand side. But isn't it on the output on the left-hand side also? Isn't it here?
Yes, but it's taking, yeah, but with a counter, your previous output now becomes the input. So it's
No,
it's gonna
I'm asking you if I wanna declare counter here. Should I put it as input or output in the entity?
Input.
Why? But it's here on the left-hand side.
Because you would have to update it.
But still, it is on both sides.
I think you refer to it with a different name, right? Count
No, it is the
versus
same name.
CNTR.
No, the same name. CNTR on both sides. Where is it?
In the entity, you refer to it as count.
CNTR. I am asking CNTR. Is it input? So I put it on the entity as input, or I put it as output.
As output. Output.
But it is taking input because it is on the right-hand side.
Yeah, but
Wait. What about this C? Is it input or output?
this is the signal.
Oh, Professor, yeah, this is a signal.
Yes. C is working as output of the and input to the OR. So C is input and output. I cannot put it on the entity. I have to put it somewhere else. Put it where? As a signal. This signal. Signal, this is where you have internal signal. It is not coming from outside. It is internal to the structure, like C. C is not an output or input. It is internal. So I have counter, this is an internal variable, and whenever I finish, whatever the value is, I put it to count. So count is on the outside world. Counter, it is internal, and it is a signal, internal signal. Clear?
Yes, thank you.
We'll continue next time on Friday. And please, you have now the tool to do 1 to 10. 1 to 10. You are ready to do those, and those already, you have them. We need just to type the program, run, debug if there are any bugs, and get the output. We have a big title that is added, and we are going to work on it on Friday. I wish you a great day and see you on Friday.
Professor, please, can you pause this lecture today?
This video?
This lecture, can you put it on Canvas today?
The slides are already posted.
No, I'm talking about this lecture.
The lecture,
Yeah, this one.
I sent you an announcement with a link to my YouTube.
Okay. All right.
Okay.
Thank you, Professor.
And it takes some time for processing. As soon as it's in the processing, I upload it. Then YouTube will do another process, and then you will get it. Okay. And all previous lectures are there also.
Thank you, Professor.
All.
Have a great day, okay?
Thank you all. Bye-bye.
Thank you, Professor.
See you. Have a good day.
I believe I gave you my cell phone number last
Thank you,
time.
Professor. Have a wonderful day.
I gave you my cell phone. If you need anything, just call me. Thank you. Bye-bye.